G'day Internet, Kale from Veza here to talk to you about SaaS. One of the most important trends of the last couple of decades is the migration to the cloud. And that includes not just data and workloads, but also all of the apps that you use for business. And that model of software as a service, SaaS, is so prevalent now that organizations maintain around 125 different SaaS apps on average. An adoption of SaaS has huge advantages. Employees can work from anywhere instead of being tied to an office. You can scale up or down as you need, and you can easily switch between tools as your needs change. But along with those benefits, we have a whole range of new security challenges. One is a massive expansion of your attack surface. Instead of all your applications being on-premise behind a firewall, that perimeter is gone, and each SaaS app becomes a potential entry point for an attacker. Some, like your CRM or HR platform, contain heaps of sensitive data like customer information, financials, employee data, but they can also expose the rest of your stack. For example, an attacker who can access your Slack instance might find shared credentials or personal information that they can spin into a convincing social engineering outreach. And there's also the sheer scale of access governance to consider. Thousands of employees, hundreds of apps, millions of records, adds up to more access decisions than you can possibly make manually. IAM teams have developed all kinds of best practices for provisioning SaaS apps, but they're hard to follow in real life. For example, everyone knows you should provision apps through groups in your identity platform instead of assigning them directly to users. But by now, many organizations find that they have more groups than actual employees. So now it's too difficult to figure out what groups an employee should belong to, and they end up assigning apps directly anyway. Over time, as employees join, move, and leave, all these unmade decisions stack up as access debt, and they make effective governance impossible. So let's have a look at how Veza can help. First, if you're not familiar with Veza, here's the 1-minute version. Veza is an authorization platform for data and app security, and we're built to help you answer a simple but vital question. Who can and should take what action on what data? Veza uses agentless read-only API access to capture metadata from your identity providers, cloud providers, databases, and of course, SaaS apps. And we pass all of that metadata and normalize it into a single schema to describe effective permissions to data and apps. And that model drives our authorization graph and lets us query all permissions across your stack. And with that information, you can develop insights into your access trends, you can surface violations of best practices, you can create workflows for governance and compliance, and you can constantly monitor your state of authorization and fix issues by integrating with ITSM and notification tools. So let's get into our demo. We're going to start on the home screen of the Veza dashboard. The dashboard is fully customizable to give you a bird's eye view of your particular top priority identity and access risks. You can set it up to show you just about anything, misconfigurations in your cloud infrastructure or excess privilege in your data lake. But today I'm focused on my SaaS apps. So let's dive in. Here we are in the Veza dashboard, and I've set up this dashboard to surface at a high level some of the key SaaS trends and risks that I'm monitoring. These can include basic but vital misconfigurations like accounts that can bypass multi-factor authentication. I can see how many I have and where they're based. I'm also tracking my adherence to best practices. I can see all of my SaaS accounts that don't map back correctly to my identity platform. These could be forgotten accounts created by local admins, or they could be lingering access from employees who've left the company. Later on, we'll dig into exactly how we find these. Along the same lines, I'm tracking all of my SaaS accounts that are assigned directly to users instead of through groups. I want to be able to see this number trending down. I'm also tracking external users like consultants and contractors. How many are there? And what sort of information do they have access to? Like our comms tools, our source code, our CRM, our financials. Next up, I'm looking at what we call high blast radius identities. These are identities that have access to a lot of resources and records in our SaaS instances and would present the biggest risks if they were hacked. We want to keep this number low and pay special attention to these high value targets. And lastly, I'm tracking specific misconfigurations for my Salesforce organizations. Each app obviously has its own unique vulnerabilities and potential misconfigurations to watch out for. So, as an example, let's dig into Salesforce in a little more detail by looking at this report. So here's my report. It starts at the org level, and I'm keeping an eye on whether any of my Salesforce orgs don't have MFA or audit trail enabled, along with a count of all the high or medium health check risks that Salesforce uses to calculate its health check score. Then I'm looking for problems at the profile level, like specific profiles that can bypass multi-factor authentication, or profiles that don't have any users attached to them. Lastly, I'm looking at the user level and finding those users with disabled IDP accounts or no IDP record at all. These are high-risk users I need to find and fix. I'm also looking at Salesforce users who don't belong to any groups. They're likely to have ad hoc access that I want to investigate. So these are misconfigurations. I really want all of the numbers on this report to show 0. But I'm also interested in applying least privilege and making sure my users don't have more access to customer and prospect data than they really need. So let's have a look at another report on access in Salesforce. And I'm tracking 3 important trends here. First, I want to know how many users have powerful admin-like permissions in Salesforce, like the modify all data permission, or how many users are able to modify and delete objects in Salesforce. Second, I'm checking my permission sets that include broad access grants. These permission sets are an easy way for a user to get a lot of access fast. So I want to make sure I understand each permission set that's showing up here and know if it's really needed. And finally, I've created a simple risk scoring report for my Salesforce users depending on how many accounts they have access to. I'm triaging high, medium, and low risk users so that I can focus on reviewing my biggest risks. Okay, so how do we actually get all of this information? And more importantly, how do we make it actionable? Let's look at just one of these use cases in more detail. You'll remember that one of our biggest risks is local accounts in Salesforce that don't map back to a record in our IDP. These are the dreaded zombie accounts, and any one of them might provide a way into the system for an attacker. And traditionally, it's been very hard to get visibility into this problem. If you're looking at your IDP, you don't see these accounts at all. If you're looking in Salesforce, they just look like any other users. So to find them, you need to put together data from both places. So let's look at the query I've built for this. We're looking for Salesforce local users, and we want to map them back to users in Okta, our IDP. In this case, I'm setting the does not relate to flag because I want to find local users with no matching IDP record. And here are my 6 users. I can dig into the details by opening up these results in the authorization graph. And here, in addition to being able to see my 6 users here, I can drill into any one of them. And I can see what accounts did they have access to? What actions are they able to perform? Read and write and create new accounts. And what groups, profiles, and permission sets give them that access. Going back to our query, I want to automate monitoring for these types of local accounts so that I can always fix them right away. So to do that, I'm going to save the query. I'll give it a name. And I'm going to create this as a critical level risk. And I'm going to set up an alert rule. This rule is going to trigger anytime my query results are more than 0. Or to put it another way, anytime this query returns any results, I'm going to use the alert rule to create a ticket in ServiceNow so that my ops teams can fix this. And I'll have an audit trail to tell me when the issue is resolved. And this same basic flow can be applied to any of the risks or misconfigurations that we've covered here today. So, with Veza, you can keep track of permissions across all of your SaaS applications, identities, and accounts in real time, and know exactly who can do what. You can continuously monitor for changes and fix excess privilege, best practice violations, and misconfigurations as they arise before they become vulnerabilities. If you'd like to take a deeper dive on what I've shown here today, I recently sat down with Tarek Khaled, one of our solutions engineers at Veza, for a longer discussion about some of the challenges of securing access to SaaS apps and how Veza can help. You can find a link to that webinar below. I'll see you next time. Thanks for watching.